Hey, what's up? It's Zane Khan from Chem 1412, section 62430 for Professor Fox. Today I will be doing experiment or lab experiment number 4, the equilibrium and Le Chatelier's principle. Today we will be doing lab experiment 4, and before we do the experiment, it's always good to understand what you're doing and why you're doing it. So we're going to do a quick overview and the background of the whole entire experiment. So copper chloride, which is one of the chemicals we'll be using today, is an aqueous solution, and is in equilibrium with copper hexahydrate. And this whole entire lab investigates how this equilibrium can be shifted to the right or left by changing the temperature and concentration of the reactants or products. So a chemical reaction occurs when reactants react with each other to form products. If the reaction is unidirectional, reactions in which the reactants create products and the products cannot convert back to the reactant, then the reaction is called an irreversible reaction. Another type of reaction is a reversible reaction, where the forward reaction forms the products and the reverse reaction forms the original reactants. In a reversible reaction, the reactants and products are never fully consumed. They are constantly reacting and being produced. There's also a dynamic equilibrium, and eventually the rate of the reverse reaction equals the rate of the forward reaction, and that's pretty much what the dynamic equilibrium is. And whenever the dynamic equilibrium is reached, the concentrations of the reactants and products remain fixed, but this does not mean that the forward and reverse reactions have stopped. Reactants are still being converted into products, and products are still reversed into reactants. However, the rates of conversion for the forward and reverse reactions are the same after a given period of time, thus resulting in no net change in concentrations. So let's start it. Here's also the Le Chatelier's principle about the whole shifting reactions from the left to the right, or the right to the left, from the products to the products to the reactants, and the reactants to the products. So the items that are needed in this experiment, let's start with the first one, which is the copper chloride solution, right here. We also have the silver nitrate solution. We have a weigh boat. We have the thermometer, which is right over here. Got the mini pocket scale. .250 ml beaker. And we have the 25 ml flask. Plastic spoon. Oh, which is right here. Grab it. Plastic spoon. Pipette. Test tube racks with the test tubes in them. 10-ounce plastic cup. And we also have the water. And then we also have the 10 ml graduated cylinder. And we also have the ice. I have to go grab that. They're in the freezer actually. And for the sodium chloride, I have it all right here in this little boat. But these are the empty ones that we're going to use in the experiment. This is just somewhere where I can put them. And for the white paper, I have it right here. So let's begin. So I also have my goggles, my gloves, and my apron on, because safety is always the most important thing. And you don't want to hurt yourself with these chemicals because they can be dangerous. Okay, so let's start out with the grease pencil. We're going to number test tubes 1 through 5. Okay. And then we're going to add 2 mLs or 40 drops of the copper chloride to each of the 5 test tubes. 40 drops. I'll just use the syringe, it'll be a lot easier. That's right here. Let's drop 40. 1, 2. So here is the 20 ml or the 40 drop, or sorry, not 20 ml. Here's the 2 ml and the 40 drops, and as you can see, it is labeled 1. I'm gonna go ahead and do it for the rest of the other 4 test tubes, and I will let you guys know how the experiment goes, and I will be right back. Thank you.